Good afternoon.
Good afternoon.
All right, so let's see. Looks like we got everyone there. Mogan. So is Skylar taking the day off?
She should be here in a second. She should be back.
Okay. So I heard you guys won by like 100 points or something. Winslow girls, is that correct?
Sorry, Mike was on. Yeah, we won by quite a bit. So we play tomorrow.
Well, listen, you don't have to get 100 points every game, right? Anyway, but no, that's good. That's good. Congratulations.
Thank you.
So when's your next game?
Tomorrow we play Chinley.
All right, awesome.
Yep, that'll be good.
So, well, that'll be good. Well, maybe just score like 50 and let the other girls have a little bit of time.
Maybe we'll see. Well, maybe I'll give him a shot.
Okay, all right, good. So, so let's see. St. John's, you guys had the day off yesterday, right?
Yep.
So, now I knew that I'd actually got an email earlier in the day saying that they were having internet problems there. So, but I was happy when it finally got resolved. But there was actually some internet problems everywhere. It was a little bit slow yesterday, but you guys were the only ones that I lost completely. So anyway, we did have a little bit of a shortened lesson, but you just want to watch that video and let me know when you do, and you'll get those attendance points back for sure, because that absence obviously was so.
And then also, I think that my attendances, some of them were marked off when I was just gone for like basketball or something, but I did like watch the videos and everything.
Okay, will you shoot me an email about those dates, so that will remind me to update those attendance records, okay?
Okay, and then also, sorry, we took the test last hour, and then could I have my second attempt open at some point?
Sure. When would work for you? Or just send that to me in the same email.
Okay, I will.
And then Skylar, you can if you guys take it at the same time, that's great. Or if you need to do it at different times, that's okay too. Okay. So just let me know. All right. Anything else?
Mr. Strong,
Yes.
I wasn't able to take the second intent of the Chapter 7 test.
Okay.
And
So unless if any of you want it like right after class, let me know right now. If you want it like later, tomorrow, Monday, or whatever, just the best way is to shoot me an email.
I think I can do Monday right after class or before class.
Right before class?
Yes, that would be
Okay. Will you send me an email?
I would. Yes.
Just that'll help me. I'm not saying my memory is bad, but yesterday a student asked me to open up a quiz, and I mean I didn't even remember it for 5 minutes. I don't know. It was kind of a rough day, but anyway. So the emails are nice because then I can keep track and make sure I do everything exactly when you want it. But like some of you like to do it right after class, then I can remember it that long. So, all right. Well, let's go ahead and get back to 8.2. So we were on repeated use of integration by parts. So this will give you guys in St. John's a little bit of a review as far as what we did. It's a technique of integration is what we're doing. Okay. So this is example 3. So we're almost done with the first half of this page. So what we're going to do here is say, well, what if we have to use integration by parts more than once? Okay, that could happen. All right, so what we're doing here is we pick one of the functions to be our u and the other to be the dv. Because we learned yesterday that they're just like with derivatives, there's no product rule for integration. And so when you have the product of two functions, you can't just integrate them separately. So this is how you do it. So you pick one to be u and the other to be dv. So the one that you pick u to be u, you take the derivative of that. And so you say your du is 2x dx. The one you pick to be dv, you take the integral of that. So the integral of e to the x dx is e to the x. And then the formula is that that the integration is u times v minus the integral of v du. Okay, so I'll write that down so you can kind of see what I'm doing here. So it's u times v minus the integral of v du. So u times v, so x squared times e to the x minus the integral of v du. So e to the x times 2x dx. Okay, now,
Mr.
yes.
Is that u times v minus the integral of v du? Is that the integration by parts formula?
Yes, that's the integration by parts formula that we're using with every problem. Okay? So, so then when you get to this point, you compare this integral to the one you started with just to make sure that it's not more complicated. Because if it's more complicated, then you switch your u and your dv. So this one is less complicated than what we started with, but it's still the product of two functions. So we have to use integration by parts again. So we just, this first part, that's part of our answer. So then this part we have to say, okay, well, let's let u be 2x and dv is e to the x to dx. So then take the derivative of 2x, which is 2 dx. The integral of dv, the integral of e to the x dx is e to the x. So now you apply the formula again. So you bring down this first part and then minus, okay, so then this part is u times v, so 2x times e to the x minus the integral of v du. So that would be e to the x times 2x. No, v du. So e to the x times 2 times dx. I just put the 2 in front. Okay, now this compared to this integral, compared to what I started, this is simpler still. As a matter of fact, this one I can just integrate. So you bring the 2 in front, and then the integral of e to the x is e to the x. Put the plus c at the end, and now we can just watch the negatives. So minus 2x e to the x minus another negative, we'll make this one plus. So we have x squared e to the x minus 2x e to the x plus 2 e to the x and then plus c. And so that's the final answer. Now, the final thing that you might see when you compare your answers in the back of the book is that sometimes they will factor from the non-constant terms. And so like see here, there's a e to the x in each of those terms. So they might factor that out, maybe, or maybe not. And so it just, that would be the only thing. Let's go ahead and write that factored form. So you might also see this, e to the x in front, and then x squared minus 2x plus 2 plus c. So I'm not saying you have to do that. I'm just saying so you know if you compare your answer to the back of the book, it might be either one of those two. Okay, so let's see if you can do it now. So go ahead and try practice 3C or 3, whatever it is. Practice 3. All right, so Hannah, when you've got it.
So I got 5x squared e to the x minus 10x e to the x plus 10 e to the x plus c.
There you go. Okay? All right, so let me go through it again for the guys. Okay? So you pick one function to be u that you can take the derivative of. The other function to be dv that you can take the integral of. And so if we pick u to be 5x squared, the derivative of that would be 10x dx. If e to the x is dv, then v, the integral, would just be e to the x. So now you apply the formula, u times v, 5x squared times e to the x, minus the integral of v du. So e to the x times 10x dx. So that integral is simpler than what I started with. The power is 1 less. So this you bring down, that's going to be part of your answer here. Okay? This integral, I've got to use integration by parts again. So let u be 10x, dv is e to the x dx. So du is 10 dx, v, it would be e to the x. So then this integral is u times v, 10x times e to the x, minus the integral of v du, e to the x times 10 dx. And now we can integrate that, just bring the 10 out front, and the integral of e to the x is e to the x. Watch your signs though. This negative applies to everything. And so this middle term is negative, then minus a negative, the third term is going to be plus, and that's it. And if you wanted to factor out the 5e to the x, you could do that. All right, any questions? All right, so more practice. You just need to see it, and it'll start clicking if it hasn't yet. All right, solving for the unknown integral. So integrals like the one I'm about to do are used a lot in electrical engineering. So I know when this actually popped up in my differential equations class, and a lot of the electrical engineering students were doing tons of these type of integrals. Okay, so Now, it has a different little trick to it, okay? So just kind of watch it, and then we'll apply it to the answer, but it's just a little bit different here, okay? So let's say we have e to the x cosine x, okay? So then we say, all right, well, let's let u be e to the x, and dv is cosine x, because I can actually take the derivative or the integral of either one of those, easy enough, okay? So the derivative of e to the x is e to the x dx. The integral of cosine x dx is sine x. So now when I write down using the integration by parts formula, I have u times v, so e to the x sine x minus the integral of v du. So that would be sine x times e to the x dx. Now, when I compare this integral from where I started though, I'm getting a little nervous. I would as a student, because while that integral isn't any harder than what I started with, it's not any easier either. Okay? So that's sort of maybe a warning sign that something wacky is about to happen. Well, it's about to happen. All right, so when I do the integration by parts again on this part, whoops. Okay. So you just bring down the first term. So let u be e to the x, dv is sine x dx. So the du, the derivative of e to the x, is e to the x dx. The integral of sine x is negative cosine x. So now you apply the integration by parts formula again, and you have u times v, e to the x times negative cosine x, minus the integral of v du. So that would be negative cosine x times e to the x dx. Now, when I kind of deal with all these signs, so this is minus a negative, so that becomes plus, and this is minus a negative with a negative, so these two will make it plus, but then this makes it minus again. Okay, now the wackiness begins, because as I look at this integral, this is exactly the integral that I started with. Okay? And that happens when you're doing these, is sometimes you'll end up with the same integral you started with. So obviously, but it's actually, we're going to be able to work it out. It's not like we've wasted any time, but the way we do it from here is going to be a little different. Okay? So the idea is this. Let me leave this and come back to something else. Okay? So let's say that we have our original integral is equal to partial answer A, partial answer B, minus the original integral again. Well, so what the algebra trick here is that if we add the integral to both sides, we get 2 times the integral that we're looking for is equal to A plus B. And so the answer will be A plus B divided by 2. Okay? So now let's apply this to the problem at hand here. So I have the integral equals e to the x sine x plus e to the x cosine x minus the integral. So if I add the integral to both sides, I get 2 times the integral is equal to e to the x sine x plus e to the x cosine x. So my final answer, I divide each side by 2, and that's it. So it's e to the x sine x plus e to the x cosine x, all divided by 2 plus c. All right, any questions? All right, let's see if you could do practice 4. And it's going to be like this, where it's going to be recursive. All right, so Hannah, when you've got it, or if you get stuck.
I got negative e to the x cosine x plus e to the x sine x over 2.
That sounds about right. So you just said these in a different order, but it works. Okay. All right, you guys want me to go through it? Anybody?
Yes, please.
Okay. All right, so we're calling our original integral I. So first we're going to use integration by parts on that. So u equals e to the x, dv equals sine x dx. So the derivative of e to the x is e to the x dx. The integral of sine x is negative cosine x. So now this is applying the integration by parts formula. So the integral is u times v minus the integral of v du. Okay? So, questions so far? All right, so now this next part. So now we're going to integrate this. So we have, so the integral of cosine x dx, or ex, have u be e to the x, dv is cosine x dx. So du, the derivative is e to the x dx, the integral of sine x. So now we get u times v. So e to the x times sine x minus the integral of v du. So sine x e to the x dx. So this is the integral that I started with. So I'm calling this I. So if I add I to both sides, then I get 2I is this right here. And I just reordered it so that we just put a negative in the middle. So e to the x sine x minus e to the x cosine x. And then divide each side by 2, and there you get your final answer. And then don't forget the plus c at the end. Okay? Questions? All right, so part 5 is on what we call reduction formulas. We're going to do this later. I like how it's presented better later in this chapter, so I'm just skipping that for now. All right, and then the integration by parts formula for definite integrals, there's no difference in the formula. It's the integral of u times v dv is still the integral of u times v minus the integral of v du. The difference is that you have your limits of integration. Okay, so in reality, the difference is when you're doing these in real life, the integration by parts, if you have limits of integration, I just say put them in the calculator. Your calculator knows integration by parts formula. Okay, now, so I'm not going to really take extra time doing these by hand when you've got plenty of other ones without limits of integration that you can practice on. So, but I want to make sure that you can put it in the calculator. So that's a good skill. So this is find the area of the region bounded by the curve y equals x e to the naught minus x, and the x-axis from 0 to 4. Now, remember with area, to find the area, you find the integral. So from 0 to 4, we're just asked to find the integral for this, okay? And now, so we actually did these in chapter 5. The area under the curve was the integral. But we didn't have any like this, where you would, to do it by hand, you'd have to do integration by parts. So, but as far as putting it in the calculator, you could do it the same way. All right, so let's go ahead and have you do practice 6. And put it in the calculator. And come up with the answer. All right, so Skylar, when you've got an answer.
164.794.
Okay. All right, 164.794. So I went ahead and did it, worked it out, but that's what you get from the calculator. Now, so Skylar, how did you put it in the calculator?
The integral from 0 to 4, and then x e to the x dx.
Okay, so you use the math key, math like 9
Yeah.
or whatever? Okay. All right, so what I want to show you is an alternate way to do areas under the curve with the calculator. And I don't know if I've taught you this before or not, but it's worth taking a minute. See, if I have to find the area under the, if I have to find the integral, then I do it just how you said, Skylar. I do math. So math 9, and then you get the integral, and then you type stuff in, right? Okay. Now, but if I'm asked to find the area under the curve, then I like to do it a little differently in the calculator. That what you can do, and I want you to kind of do this with me if you haven't done this, is put the function in for the y equals. So x e to the x. So x e to the x. Okay? So you're just putting the function in for the y equals. All right? Then instead of graphing or whatever, if you do second calc, and then option 7, then that's saying it's going to take the integral of that function. Okay? And so now, so then it comes up lower limit, and you type in 0. Upper limit was 4. And see the thing, so it gives you the same answer. The thing that I like about this is it actually shows you the area under the curve. So that way, if you've got something wrong, or you have to take one function minus the other, and it's a little more complicated, you can actually see, okay, I'm actually doing the wrong area or something like that. Okay? All right, any questions on that? But you get the same answer. Okay? So, but I just like this method for area under the curve. Okay. Whoops. All right, next, tabular integration. Now, I'm hoping you ladies have all practiced a little bit with this. I know the guys, you didn't get that where I wanted you to try some of these, because tabular integration is a way to organize the calculations in a way that saves a lot of work. But it really helps if you've done a few of them already. You'll see how the organization helps. So we'll just, but I want to show you this anyway. Okay, so, and the way that I'm going to show you is actually different than how the book does it or whatever, any other method. Okay, so this is kind of my own method of doing this. So what I'm going to do is, after I show you this and have you try to apply it on the paper, then, you want to make sure you take good notes on at least the practice problem. So you can just watch me on this one if you want. So you set up your integration by parts, and normally we have our U and our dV, okay? All right, oh, don't write down this part. This is just kind of showing you how we've normally been doing it. So U times V minus the integral of V to U, and then we go through, and sometimes you have to do it again and do it again. And sometimes you have to do it 3 or 4 times, maybe, okay, depending on how evil your professor is, okay? So that's kind of what we're trying to do, is create a shortcut for it, or a way to organize it. So the shortcut is tabular integration. It's like making a table. So what I do is I have 3 columns, okay? The first column is just for plus and minus. The second column is for derivatives, so I just put a big D. And the second column is integrals, and I just put a big I for that. Okay? And so for the derivatives, you're taking the derivatives of u, and then the integrals for dv. Now, this is important in my method, that in my method, the first row, you skip, you leave this blank, and all you do is you write down what it is you're taking the integral of. So the dv e to the x goes there. Okay? Now, on the next row, you always start with a plus, and then you put the function that you're taking the derivative of, x squared, and then you go ahead and integrate e to the x, which is e to the x. Okay? The next row, you alternate these signs here. So it goes from plus to minus, and then you do the derivative here, and then you integrate here. Well, it's great because e to the x, the integral is always e to the x. And you keep going. So this is going to be plus. The derivative of 2x is 2. The integral of e to the x is e to the x. Well, you keep going until you get a derivative of 0. And then actually that's where you stop. So you're actually not going to go past the blue line. When you get a derivative of 0, you're done. And now you're ready to write the answer, believe it or not. So the answers are, so with the pluses and minuses, each row is going to be a term of your final answer. And so your final answer is plus x squared e to the x minus 2x e to the x plus 2 e to the x, and then you slap the c on and you're done. So when you have to do multiple uses of integration by parts, this is amazing. This is really helpful.
And
All right, so go ahead.
Will that work on all of them? So like the problems that we did a little while ago?
Well, it'll work on if one function you can keep taking the derivative till you get to 0, and the other function you can easily integrate it. Those are the ones that'll work. Okay. So if you taking the derivative and it doesn't end up going to 0, then you got to do it a different way. Okay? All right, so go ahead and try practice 7. And I'll leave this up. All right, so Skylar, what do you have?
X cubed EX minus 3x squared EX plus 6x EX minus 6 EX plus C.
Yep, so this is it right here. Okay. Any questions on that? All right, so just like I was saying to Joey, this tabular integration is effective if one function can be differentiated repeatedly to 0, so it breaks down each time, and the other can be integrated repeatedly without difficulty. Okay, so let me just kind of compare how I set it up versus the book or some other methods. Okay. See, the thing I don't like about how the book does it, and even how some online instructions do it, is that they have the coefficients in the middle, the plus or minus, and then they have you go down. And I just like it when it's all nice and neat in one row, and you have your plus or minus in front, and you just kind of deal with it. And the only thing about mine is you have to skip the plus or minus and the derivative in the first row. Okay. All right. Well, let's have you try practice 8. All right. So Chloe, when you've got it.
X cubed sine x plus 3x squared cosine x minus 6x sine x minus 6 cosine x plus c.
Okay. I thought you said plus 6. Did you have a plus 6? Cosine
Yeah.
X? Okay, so
I said negative 6x sine x minus 6 cosine x plus c.
Oh, okay. I just heard you wrong. Okay.
Yes, sir.
So, would anyone like me or Chloe to go through this one? Okay. All right. Well, that's a good place to stop for today. We just finished 8.2. So we'll start with 8.3 on Monday. Now listen, you guys in St. John's, after you see the video from yesterday, try some of the problems in the book. And if you're stuck, ask me about it. And I'll go over it during class time, okay? So I don't want you guys to get penalized for that. So, all right. Well, you guys have a great weekend, and we'll see you on Monday.